So last time we said that we were going to transition from just theory into actual practice. So we're going to put our knowledge that we've gained so far to use. And we're going to talk about how you can actually prove theorems and like just statements in general, how we can prove them in a well-defined step-by-step procedure. And let's try to put it to use. Okay, so what do we want to prove and how do we want to prove it? So what we want to prove today, and I chose a rather interesting example. We want to prove this statement: if A is less than B. Oh, hold on. We have to be more specific than that. If A and B are positive numbers, so I just indicate that like that by putting a 0 over here. So this just means that A and B are positive. Then after multiplication by -1, you don't just get 0, -A, -B. We have to flip it around, and usually that's just something that people tell you, right? We have to flip the inequalities around when you're multiplying it by a negative number. And it's just something that you use for granted without actually knowing why it's true. So now we're just gonna apply logic to understand why this is true. Okay, so how do we begin? I guess first things first is we can rewrite this entire English sentence here into a logical symbols, a string of logical symbols. How are we going to do that? Well, let me just assign this particular statement here with the letter P, and I'm going to assign this particular statement here with the letter Q. That's something that we can do. We have done this kind of thing many times before. So if P then Q, well, we know how to write that in terms of logical symbols and statements and all that kind of stuff. We've dealt with this before. To write this, convert this into logical statements, we just have to write P arrow Q. And this means if P then Q, just exactly as the above right here. But right now this is just a string of symbols and we don't know how to prove it yet, right? So to actually prove it, we need to look back on to the second video, I believe, from this lecture series, which talks about how do you make a good argument. So just a refresher on that, we said that, well, let's talk about what an argument is first. So an argument basically consists of what you want to use as evidence and also what you want to use as a conclusion. So an evidence, for example, could be he went home before 6 p.m. and the conclusion is he couldn't have killed her or something like that. So you're using an evidence in order to justify a conclusion. You're using one piece of information to justify another piece of information, and well, that's looking very, very similar to this. So this is basically the same thing as letting P be our evidence and letting Q be our conclusion, right? We're using P as our evidence in order to justify that Q is right, right? We're trying to use the information provided to us to conclude something else. Okay, so how did we decide on whether an argument is good or not? Well, we said that an argument is good if the truth of our evidence leads to the truth of our conclusion. Alright, so the truth of P leads to the truth of Q. Okay, that seems pretty straightforward enough. Alright, so we did this before. We did an example of showing whether an argument is good or not. We had examples of good arguments and bad arguments, and in those examples we constructed a truth table in order to figure out whether an argument is good or not. Because with a truth table you can see all possible universes, you can see which one of them is true, which one of them is false, and so on and so forth. So let's try to do that. What are the possible universes? Well, there's 4 of them. 1, 2, 3, 4. This is P, this is Q. Well, say we have a universe where both P and Q are true. Maybe a universe where P is true, but Q is false. Maybe a universe where P is false. Well, 4 should also be false, and then false true, and hold on, yeah, and false false. Yeah, so these are the 4 possibilities, and there's no other possibility that you can have. This is every case that we're looking at. This is all that matters. It's on this truth table right here. Okay, so which ones are evidence? That's P, and I'm just gonna label evidence as red and conclusion as blue, so you can, well, color code it so you can keep track of what's happening, of what is what. So, okay, if the truth of our evidence leads to the truth of our conclusion, okay, so our evidence is P. We want to make sure that the truth of our evidence leads to the truth of our conclusion. So really, we want to be just concerned with looking at this part of the table here. We want to just, get rid of the bottom half because it does not relate to the question at all. Our question asks whether or not the truth of our evidence leads to the truth of our conclusion, and that has nothing to deal with like false evidences. Yeah, we just don't want to concern ourselves with this bottom part. It's not part of the question that we're trying to answer here. Okay, so what does this truth table tell us? Well, it tells us that either one of 2 possibilities can happen. Either we're in universe 1 or we're in universe 2. Those are the 2 possible universes. Okay, so let's see what happens. So the truth, okay, in universe 1, the truth of P, it does lead to the truth of Q. So universe 1 is good. That's what we want. And we end up with a problem here because we haven't quite answered this part yet, right? Because we still have universe 2 to deal with, and universe 2 is bad because the truth of our evidence does not lead to the truth of our conclusion. See, P being true leads to Q being false. That's not what we want. But does that mean we're stuck? We're at a dead end? Is there nothing else we can do? Well, no. Because what this table really is telling us is, hey, either we're in universe number 1 or we're in universe number 2. So we're just reduced to 2 possibilities here. Either we're correct or either we're wrong. Either we're in universe number 1 or we're in universe number 2. So we need to show somehow that we are in universe number 1, okay? And, well, that's the purpose of our evidence. We have to extract some important information from our evidence that leads to us being able to conclude that we are in universe number 1. So how are we going to do that? We are in either one of the universes. So we can start at this common ground. P is true. Now this statement over here, it's something that is shared by both universes 1 and 2. This is, you can say, a valid starting ground for us to be in because, well, no matter what the case is, P is always true. This is an information that you can rely upon. You see, even with the uncertainty, either universe 1 or universe 2, even with that uncertainty, we can always rely on the fact that P is true based on this truth table. Alright, so right now we just wanna go step by step in such a way that it leads to some evidence that we are in universe number 1. Alright, so P is true. Let's write that down in English so it's better to understand. So what is P? P is this thing above here. So that's 0 is less than A is less than B is true. Okay. So what we can do is we can subtract A from like the entire inequality. What we get from that is negative A is less than 0 is less than B minus A. And we know that this is a valid thing that we can make whenever you have an inequality and whenever you add both sides by some number, that inequality will still remain true. Because we're just modifying a true statement, and as long as that modification doesn't break any rules, then the resulting statement is also true as well. And well, we're still not quite done yet. It's still this, this doesn't look like the evidence that we are looking for. So we can still keep trying to move forward. Let's see. Let's try to subtract both sides by b, see what we get, let's see, negative a minus b less than negative b, and this is, well, you subtract b, this is just negative a, and this is true as well. We're just making valid mathematical changes here. And, well, negative a is less than 0 is true, right? So if negative a is less than 0, then we can just like attach that right here. Negative a is less than 0 is true. And well, negative a minus b, like we can just really get rid of that. Why? Because this is just extra piece of information that we don't need to know, and we're still not changing the truth value of the statement. We're just getting rid of unnecessary information, but the rest of the information here, that it still holds true. We're just getting rid of the unnecessary details. So okay, we have negative b is less than negative a is less than 0 is true. Does that look like the evidence that we need? So let's look up here. We have q, and q stands for 0 is bigger than negative a is bigger than negative b, but we can rearrange that somehow, You see, if we flip the order of these three around, say negative b first, and then negative a, and then 0, then if we flip the inequalities around too, then that would still make sense, right? This is something valid that we can make. That rather looks ugly. Let me just rewrite that for a bit. Then this and this is equivalent. You flip the order around and you also flip the inequality around. This results in an equivalent statement. So this thing also represents the statement Q. And well, that looks exactly the same as what we have here. Negative b less than a is less, negative b is less than a is less than 0. In fact, this is Q. So what we have Q is true. Okay, Q is true. Does that look like the evidence that we need? Well, P is true leads to Q is true. Okay, P is true leads to Q is true. Let's try to use that as an evidence. Okay, and so what does that tell us? Well, P is true leads to Q is true, so well we must be in universe 1, right? And well, that's a good thing. So I guess we're done. So that's it. That's the proof of this statement here. If 0 is less than a is less than b, then 0 is greater than negative a is greater than negative b. This is the proof of the statement, and we have, well, our step-by-step solution on how that all works out. And let's try to summarize what we did. Let's just do that over here. So we were proving this statement. Let me just color code it again. And well, what did we do to prove it? What were the steps that we take? Well, first, we assumed that P is true. We made this our starting point, and then we made it our goal to show that Q is true. So the way to prove this is, well, you have like, well, let's just call it resources, and then you have goal. So one resource that we have, one piece of information that we can rely on is P being true, right? That's something we can rely on, and we've talked about why before. So our resources is P, and our goal is Q. So this is how you prove the following statement. You make P as a resource and you make Q as a goal, and well, you have to modify P somehow in order to reach the goal. So there's some hidden connection between these two, and you have to, well, work it out one by one, just like what we did over here. And this is, well, a rather straightforward way of proving something. In fact, there are many different ways in which we can prove, well, the same thing. So let's try to figure out a different way, okay? Well, here's a different way. Instead of showing that we are in universe number 1, we can instead show that universe 2 does not exist. If we can show that universe number 2 does not exist, then that leaves the only other option to be universe number 1. So that accomplishes the same thing. So this is a different strategy that you can use. You can prove that universe number 2 does not exist. How do we do that? Well, let's examine universe 2 in more detail. Universe number 2 is one where P is true and Q is false. So let's try to examine that here. Okay, so our resource now is P is true and Q is false. And our goal now is to show that this universe does not exist. I'm just going to abbreviate that. Alright, so we have our resources. This is what universe number 2 looks like. And how can we go from here to here? Okay, let's try to do that. Let's write down P is true and Q is false down here. Well, P is, if I can remember correctly, it's this. Yeah, it's this is true. And Q is false is, what did we do? Right? Okay, let's use this version because this is much easier to deal with. This is negative B, negative A, and 0. Okay, so negative B, negative A, and 0 is false. Well, if this is false, then if we just flip this statement around, if we create the opposite of this statement, then it would be true, like logically speaking, you know? So how do we create the opposite of this statement? Well, let's rearrange everything around. So instead of negative B, negative A, and 0, let's say this is on the number line, let's flip everything around. We can instead write 0 is less than negative A is less than negative B. And so now this would be true. And these two things over here, this thing and this thing, red and blue are equivalent. Yeah, they're equivalent statements. If this one is false, if a statement is false, then, well, the negative of that statement is true, just based on basic logic. So these two things, they're really equivalent statements. They convey the same piece of information, and I want to be using the version blue better because it will be more applicable to the things that we will be doing. Alright, so these are our resources. See, we have modified this particular statement in a way that will be more beneficial to us as we work through this problem. Okay, so what can we do here? Well, let's try adding a on this inequality right here and see what we get. So we get a is less than 0 is less than negative b plus a, right? Let me just rewrite that as a minus b. Okay, we have a minus b there is true. Okay, well, let's just say it in a different way. Let's just say a minus b is positive, right? And that follows directly from this statement, right? Because a minus b is bigger than 0, a minus b is positive. So cool, we just rewrote this statement at the top into something that's more, well, something that's more readable, something that's more applicable to us, and you'll see why. So this is true. Next, we still have this piece of the puzzle to work with. What can we do with that? Well, let's see, let's try subtracting b on both sides and see what happens, yeah? So 0, well, it's just turning into negative b, and a just turns into a minus b, and b minus b is 0. And so what we get over here is a minus b is less than 0, which means that a minus b is negative. And well, since this statement is true, we didn't break any rules, we just subtracted by b. That's a valid thing that you can do. So this still remains true, this statement still remains true, and well, this basically just directly follows from that. So this should also be true as well, because it follows from the above statement, and the above statement is true. So what's the problem here? Well, the problem is a minus b is positive, that's true, and a minus b is negative, that's true. And that's basically saying that some number is positive and that the same number, a minus b, the same number is negative. Now, a number can't be both positive and negative at the same time. So what does that imply? Well, it implies that this universe doesn't exist. It breaks the foundation of logic. Like this is not supposed to happen. So this universe couldn't have existed in the first place. No universe can exist where P is true and Q is false. It just doesn't happen because it creates this logical paradox kind of thing. And well, that means that universe number 2 can't have existed in the first place. It's bad. It's a bad universe. It doesn't make sense. Universe number 2, it's not really there because it can't exist. It's weird. It causes weird things to happen. It causes the same number to be positive and the same number to be negative as well. Just get rid of it. Don't think about it anymore. And what are we left with? We're left with universe number 1, which is what we wanted to show. We want to show that we are in universe number 1 because that means that the truth of our evidence leads to the truth of our conclusion. As you can see here, truth of evidence leads to truth of conclusion. This is the only option available. So what have we shown here? We've shown that this is in fact a good argument. We've shown that using P as an evidence to justify Q is valid. It's a good argument. There's no flaw in it at all. And we've done that in 2 different ways. Okay, we could either have a direct proof or we could have this indirect proof, and this is this is better known as proof by contradiction. And maybe you've seen it somewhere before, maybe you've read about it somewhere before, maybe you've read other examples, and well, now you understand the logical foundations of why this strategy works, and I hope that you find it interesting. In fact, there's many more strategies, there are many more proof strategies that we're going to discuss, but that's the end of it for today's video. There's lots of things, there's induction and a bunch of other stuff, and we'll cover those in the next few videos, and after that will be the end of this lecture series. So thanks for watching.